All right, good morning, everybody. Today is Thursday, October 22nd, 2015, and this is Before the First Cup with Jules here at UCY.TV. Happy Thursday, everybody. Hope you have some energy. I'm pretty burned out. It is 62 degrees. 62. Yes, it's 62, not 32. Thank goodness. Degrees and cloudy here in upstate New York. Looks like we're going to have a warm up for a few days. And this probably will be one of the last, I am guessing. We're getting near the end of the weather being pleasant for us. So where do we leave off yesterday? I don't really have a big show in mind today. I'm kind of brain dead, but we'll take a look at what we did and see if we can do a little bit more freaky mad science. We did a show yesterday called Presidential Council on Bioethics, BioWatch, and Biosensors, and I had lots of technical issues yesterday, and it took me probably until about 9 o'clock last night to finally get the show edited, the dead air cut out, and the length proper with all of my links. So it was a long road yesterday, and I don't think I've quite recovered. We looked at, I don't even remember. It was such a long day. Yesterday was horrible. You don't even know. I don't know. We looked at all kinds of crap that honestly right now I don't even care about. We looked at bioethics and the lack thereof, as well as a bunch of other things. And I don't even feel like talking about any of this stuff today. So I don't know. I didn't find anything that even caught my attention really today to talk about, or anything that pushed the red button, anything that fired me up over my coffee. I tried really hard too for about an hour. So I think we're just going to kind of read stories that have nothing to do with each other and see if there's something that gets me fired up, because again, another day that I wish I was in bed. I don't know, man. This whole last week or two, I just have felt like I am out of it. I come out here and I'm still half asleep. More so than normal, though. Just really fuzzy-brained, where I don't really have any neuron connections going on. I found a story the other day titled, DARPA Wants to Jolt the Nervous System with Electricity, Lasers, Sound Waves, and Magnets. Let's read that one. Says, and we've looked at a lot of this. I mean, there's all kinds of mad science. It's not a surprise anymore. It doesn't even get me excited anymore. Viewing the body as a chemical system and treating maladies with pharmaceuticals is just so 20th century. And I thought we read something that said that exact same thing yesterday. In 21st century medicine, and yeah, we're looking at this 21st Century Cures Act that's going to be all about getting rid of any protections that were left by any type of regulatory agency and just opening the door to direct-to-consumer from pharmaceutical. But in the 21st century medicine, and that's our whole precision medicine federal initiative, doctors may consider the body as an electrical system instead and prescribe therapies that alter the electrical pulses that run through the nerves. That's the premise of DARPA's newest biological program anyway. It is called the Elect RX program, and we read about this probably 6-8 months ago when they first were talking about this. Oh, every day when the show starts, my machine wants to reboot. Says that's the premise of DARPA's newest biomedical program. Anyway, the Elect RX program aims to treat disease by modulating the activity of the peripheral nerves that carry commands to all of the organs and muscles of the human body, and then also conveys sensory information back to the brain. Now, I don't know if this is the story or not, but I read a story yesterday. Oh, this is the story. So wait, we'll get there, because there was something very interesting in here. So they're talking about using these electrical stimuli as well as like magnetic and sound waves now for treating the body. And we know that there's been a lot of alternatives as well as ancient medicine that has talked about this stuff for a long time. And of course, the 20th century medical establishment has called it all absolute utter hooey and says that it's, magic rather than science, that it doesn't work and just take your pills and shut up. Well, it seems that now there's actually money going to study some of this. It says yesterday, and DARPA's already shown how they can erase and insert memories into the brain using electrical impulses as well as flashes of light and things of that nature. So it doesn't surprise me at all. Yesterday, and this was October 6th, so it must have been October 5th, DARPA announced the first of 7 grants under the Elect RX program. The scientists chosen are doing fairly fundamental research because they are still in the early stages of electric medicine. They'll investigate mechanisms by which to stimulate nerves and map nerve pathways that respond to the stimulation. Now, there is the golden key. That's what they want to do. They're not looking to cure you or me like they tell us every time. No, and they are not looking to help the poor dying patient. No, we are but mere guinea pigs. They are working in treatments for disorders such as chronic pain. Oh, look at this. Post-traumatic stress disorder. Yes, that always seems to be a key. And inflammatory bowel disease. It makes you go, huh? Well, we'll find out why. The proposed stimulation methods are fascinating in their diversity. Researchers will not only stimulate nerves with jolts of electricity, but they will also use what? Yes, pulses of light, sound waves, and magnetic fields. Whoa, it's messed up. 3 research teams using electrical stimulation will target, and here we go, they are targeting the vagus nerve. We've talked about the vagus nerve many times. The vagus nerve is a direct connect from your gut and your gut bacteria to your brain. They have already found that there is a direct connect between your microbiota and your emotions. You have lots of bad bacteria in your gut and you have a tendency to be depressed. You also have a tendency not to be very healthy, and your body systems don't quite work well. Well, listen to this, because the vagus nerve for them and the epigenome is like the Rosetta Stone to figure out a lot of the mysteries of the human body. Well, here they go. 3 research teams, including 3 research teams using electrical stimulation, will target the vagus nerve, which affects many different parts of the body. IEEE Spectrum, which is a publication that we're reading right now, but I get a lot of good news out of here, explored the medical potential of the vagus nerve hacking in a recent featured article, writing, quote, "Look at an anatomy chart and the importance of the vagus nerve jumps out at you. Vagus means wandering in Latin, and true to its name, the nerve meanders around the chest and the abdomen, connecting most of the key organs, the heart and the lungs included, to the brainstem. It is like a back door built into human physiology, allowing you to hack the body's systems." Now, that's exactly what I want, is DARPA finding ways to hack my body's systems, including my heart and my lungs. It says the light-based stimulation research comes from the startup Circuit Therapeutics, and the company was co-founded by Stanford's Carl Deseroth, one of the inventors of, and we've read about this, optogenetics. And this is something that DARPA's been using for the PTSD and getting rid of inserting the new memories. One of the inventors of optogenetics, a new technique that inserts light-sensitive proteins into neurons and then uses pulses of light to turn these neurons on and off. And under a DARPA grant, the researchers will try to use pulses of light to alter neurocircuits involved in neuropathic pain. Yes, and memories. They don't mention that. To tweak the nervous system with sound waves, Columbia University's Elisa Konofagu will use a somewhat mysterious ultrasound technique. In an email, Konofagu explains that it is already known that ultrasound can be used to stimulate neurons, yes, and to open up the blood-brain barrier. We discovered I had a new story on that. But with this DARPA grant, she hopes to figure out how it works. Her hypothesis is that as ultrasound propagates through the biological tissue, it exerts mechanical pressure on that tissue, which stimulates specific mechanosensitive chemicals in the neurons and causes them to turn on. The final project will rely on magnetic fields to activate neurons using a technique that can be called magnetogenetics. An MIT team led by Polina Akaleva will insert heat-sensitive proteins into neurons and will then deploy magnetic nanoparticles that bind to the surface of those neurons. And when exposed to a magnetic field, these nanoparticles heat up and activate the neurons to which they are attached. Figuring out how to alter the activity of nervous systems with these various tricks will be a pretty impressive accomplishment. But in the DARPA world, achieving that understanding is just step one. And next, the agency wants its grantees, and this is that DARPA money that I talk about all the time, sprinkled at all these universities. The agency wants its grantees to develop quote-unquote closed-loop systems capable of detecting biomarkers that signal the onset of disease. Yes, this is going to be our little nanorobot doctors, and then respond automatically with neural stimulation. Spectrum covered the first such closed-loop neural stimulators in a recent article stating, quote, the goal of all these closed-loop systems is to let doctors take their expert knowledge, their ability to evaluate a patient's condition and adjust therapy accordingly, and embed it into an implantable device. And there you go. I mean, come on. So now we are going to hijack the vagus nerve to give ourselves access to most of our organ systems in the body and get a direct connect to the brain. And I will guarantee you that they're going to do this through nutraceuticals of some kind through the gut. We looked at that in depth back a few months ago, and it was pretty disturbing, some of the things that they already were looking at with genetically modified foods that then could deliver some sort of RNA switch flipping or protein or whatever they want into our systems. So here, now let's read this IEEE story about the vagus nerve. The vagus nerve backdoor for brain hacking. It's called Doctors Stimulate a Nerve in the Neck to Treat Epilepsy, Heart Failure, Stroke, Arthritis, and a half dozen other ailments. This is a bottle of pills, says JP Enrico, showing me something that is obviously not a bottle of pills. Enrico, who is co-founder and CEO of ElectroCore Medical, so it seems like there's quite a few of these electrical stimulation companies popping up, is holding the GammaCore, a non-invasive vagus nerve stimulator. And if ElectroCore's R&D work holds up, this device is about to turn decades of evidence about the importance of a single nerve into a new kind of medicine. An electrical therapy as benign as a morning swim and as straightforward as popping a pill with your coffee. Look at an anatomy chart, and this is the quote that they had taken out for that other story, and the importance of the vagus nerve jumps out at you. Vagus means wandering in Latin, and true to its name, the nerve meanders around your chest and abdomen, connecting most of the key organs, heart and lung included, to the brainstem. It's like the back door built into human physiology, allowing you to hack the body's systems. Vagus nerve stimulation, or VNS for short, got its start in the 1990s when Cyberonics of Houston developed an implanted stimulator to treat particularly tough cases of epilepsy. That application was just the beginning. Researchers soon found that stimulation had the potential to treat a variety of ailments, including painful neurological conditions such as migraine headaches and fibromyalgia, inflammatory problems such as Crohn's disease and asthma, and psychiatric ailments such as depression and obsessive compulsive disorder. Scientific enthusiasm notwithstanding, the clinical history of VNS, and that was for vagus nerve stimulation, has been mixed. Trials with patients suffering from treatment-resistant depression produced good results, but not quite good enough to convince the government-run insurance programs to pay for its use. This past August, a stimulator produced by Boston Scientific performed poorly in a major trial with heart failure patients, and Cyberonics and its competitors are still figuring out what signals are best to send along the vagus nerve to tap into the brain system and to fix what ails us. Now, one of the things I'm wondering here, and I don't see in what we've read so far, is was there FDA approval on the Cyberonics device since the 1990s to start treating people? Doesn't that seem a little odd that we're like treating something as important as the vagus nerve that connects to all your main systems and your gut and your brain, and they're bitching that the insurance companies won't pay for it? But was this FDA approved? Well, let's find out, because I don't know that answer. This just seems like a really out there treatment that would be considered experimental. Cyberonics and its competitors, are still figuring out what signals are best to send along the vagus nerve to fix what ails us. Progress has been excruciatingly slow, and treatments typically require implanting of a pocket-sized pulse generator into the patient's chest, which is wired to a pair of electrodes circling the vagus nerve in the neck. Jesus! And these trials involve patients for whom, and here we go, all other options have either failed or been ruled out, and who are willing, and here's the informed consent, to undergo an invasive, quote, treatment of last resort, unquote. So that must be how currently they're getting around FDA approval. This 21st Century Care Act will change all that. And notice DARPA is getting in the game early by sprinkling funding for all kinds of different mad science gone mad, already knowing that the 21st Century Care Act is going to open that door. But what if the VNS could be the first thing your doctor prescribed? What if, as electrocore promises, it really was as easy as taking a pill? And that's what the New Jersey-based startup is aiming for. Electrocore has developed the first vagus nerve stimulator that isn't implanted. It is a handheld device that you simply press against your neck. And that's all it takes to hack into the brain and to treat some of the most troubling conditions around. Medicine might look very different a decade from now. I'd be very interested about how this is actually working, because we had read a while back about them utilizing ultrasound to open the blood-brain barrier. And we had also found another document about ultrasound making it easy for nanoparticulates that are in the bloodstream to reach the brain once you opened that blood-brain barrier. There were a bunch of other transmission routes where it could enter the body. One was directly through the nose, intranasally. The other was through the gut and then making it through the digestive system and then being absorbed into the bloodstream. But the third way was to use ultrasound and to open that blood-brain barrier. Hold on one second. I'm scrolling. I don't know if I'm going to be able to find that story about the mouse. I just saw it. I'll tell you something. Oh, here it is. I'll tell you something that's interesting. I've been noticing over the last week or so that stories have been completely disappearing off of Facebook. And this morning, I know 100% for a fact, I posted something from DARPA last night before I went to bed on Before the First Cup, and I went to find it this morning. And again, that is like 3 stories in 2 days. It's not there. So I don't know what they're doing. I'm going to have to find a new place to start putting my news stories and then feeding them out to different places. Anyway, there is a moving infographic then in the story, and it's showing this implant as their original implant as being pretty much right between your shoulder, maybe underneath your collarbone, and between the shoulder and the neck on the right-hand side. And it sends electrical stimulation direct to that nerve. That vagus nerve looks like it's what the Chinese always called the prime meridian, I believe. In acupuncture, it runs directly down the center, connects to the center of the brain, and then runs down the center of your body from your neck, connects to each of the lungs, then it connects to the heart, looks like the stomach, the liver, the spleen, the intestines, the kidneys, the upper intestine, the lower intestine. I don't know what some of these other pieces are here. What's number 10? Oh, look at. Oh, yeah, that's my spleen. It's my stomach. Wow, how neat is this? Number 7, it says in response to damage from a heart attack, the cardiovascular system remodels itself in ways that can be dangerous. The VNS can undo this process. For diabetes, high-frequency pulses can cut communication between the stomach and the brain and seems to alleviate insulin resistance. For obesity, temporary blocking of traffic along the stomach's branch of the vagus nerve leads people to eat less. And in Crohn's disease, signals sent via the nerve spleen branch squelch inflammation in the gut. It says the idea that this single nerve can have such a profound effect on so many different organs and ailments may seem far-fetched. And to understand the underlying logic of this treatment, consider anatomy of the vagus nerve and where it connects to the brain. The nerve terminates in the brainstem to a structure called the nucleus tractus solaris. The NTS is a junction in the brain, explains Milton Morris, who until recently was senior vice president of R&D at Cyberonics. From there, the vagus nerve signals travel to other important brain structures with bewildering Latin names such as the locus coeruleus and the dorsal raphe nuclei, and most of these structures produce neurotransmitters. Ding, ding! The chemical brain cells used to communicate that have an inhibitory effect, decreasing a neuron's excitability or increasing a neuron's excitability. Remember, we took a look at some of the experimentation, and I don't know if we ever actually got to that super soldier story, and I've had many crashes since then, but maybe we'll have to try and get back there. I don't even think I have that up anymore. But we had read about some research that DARPA was doing on mice in regards to quote-unquote super soldiers being able to make soldiers immune to pain or stress on the battlefield by having a direct connect joystick, literally joystick push button to stimulate the release of chemicals such as dopamine or adrenaline in the brain when their biosensors showed that they were facing a stressful situation or fear. Anyway, back to the story. The anatomical perspective clarifies how VNS produces its therapeutic benefits. An epileptic seizure, for example, is the result of waves of excitation sweeping through the brain. And deploying the brain's natural dampers should, and apparently does, causes these waves to peter out. And many of the ailments now being investigated by vagus nerve researchers are likely to involve similar overexcitation or oversensitivity. Epilepsy might be just one end of a spectrum, says Enrico. And you know, we had also talked about our environment and how our environment is so polluted with different wavelengths from different devices of wireless frequencies from all these different things, from our cell phone to our wireless router to our cordless phone to our microwaves to who the hell knows what else, and now the coming of the Internet of Things, Bluetooth, all the stuff that, if you look, there was some artistic installation that was being done out of one of the Dutch countries. I don't remember where it was, but they had done this artistic installation where they had mapped an entire room of the spectrum of radio and electromagnetic frequencies that were being broadcast, and they had it cast up on an LCD panel, and they're like, look at how beautiful it is. But when you look at it from the perspective of, holy shit, that's what we're sitting in the middle of, and they're telling us that none of this has an effect on our body, it doesn't cause tumors, it doesn't cause issues, but on the other end of the spectrum, we have people who are claiming to have hypersensitivity disorder that can feel the effects of all of these electromagnetic frequencies affecting their bodies. And now we see that DARPA is investing all this money into research using not only magnetic frequencies, but ultrasounds and sound waves and all these other things to affect like our core bodily systems. How can you say that that doesn't have some sort of effect on us? It says some connections along the spectrum have been known for a long time. About 2,400 years ago, Hippocrates noted an association between epilepsy and depression, two ailments now treated with VNS. And researchers have stumbled upon, just tripped over and fell flat on their faces, stumbled upon other links more recently. Enrico and scientists at Columbia University discovered that asthmatics they successfully treated with stimulation reported fewer headaches. And electrocore, which, to me, that would be just your inflammation issues that you would have with asthma, would probably also affect your brain inflammation. Take it from someone with allergies. Electrocore found further hints of relationships between maladies by delving into patient complaints collected by the United Kingdom's National Health Service. So another federal agency, this time in the UK, handing over research data that they've collected by people who probably checked the box or not, saying you can use me for scientific research. Sorting through this data for $29.99 a month. It doesn't say that, but that's what they're doing, or they're going to in the near future. Sorting through that data helped the company identify its first clinical targets, migraines and cluster headaches, but also suggested future research directions. And the data showed that care for patients with headaches is surprisingly expensive. A bare aspirin, $100 in a hospital, as they consult doctors up to 3 times as often as average and take up to 4 times as much medication. But all this extra health care isn't necessarily to address their headaches. These patients tend to have other chronic conditions such as fibromyalgia, anxiety, and asthma that may be treatable through VNS. The data suggests that these conditions may have a common root, at least in some patients. Today, these problems are served by multi-billion-dollar pharmaceutical markets, but those drugs don't always work. Oops, did they just say that? And they just may have troubling side effects. Oops. So instead of trying to squash these electronic upstarts, some big pharma companies are getting in on the game. And like we saw yesterday, Pfizer jumped on board with the new nanorobots to treat cancer. Well, guess what? GlaxoSmithKline, yes, and they've been sued too quite a bit. I saw there was a huge lawsuit in the UK. I don't remember what it was over, but there was a lot of damage done with some vaccination that they had given out. British drug giant GlaxoSmithKline has been the most public with its support, even coining the term electroceuticals. I've been talking about nutraceuticals. Here comes electroceuticals to describe the emerging therapies. Our goal, basically, is to speak the electrical language of the nerves to achieve a higher treatment effect, says Christopher Pham, the head of bioelectronics research at GlaxoSmithKline, in a recent interview. In 2013, GlaxoSmithKline created a $50 million venture capital arm. Here's another venture capitalist, sprinkle venture capitalist money for all of this mad science gone mad. And I'm not saying that this electroceutical technology is a bad thing. I really think that they were right. Hippocrates was onto this a long time ago, as were the Chinese with acupuncture. I really think that these have a lot to do with each other. And I know that Charlie's friend, and I don't remember his name, but Charlie on Cold Reality Radio has had his friend on quite a number of times about some other electrical stimulation that cures just about everything. And it sounds very similar to this. So I'm not saying that this is quack science, because I think that they should have probably looked at this long before pharmaceuticals. But on the other hand, don't forget that you got people, organizations like DARPA and GlaxoSmithKline that are investing in this. And it's going to be something that, once they crack the secrets of the human body and how all of these systems interact together, they're going to be the ones with the keys, not you. They're going to be able to manipulate biological systems. And that is kind of like the connecting thread between all the stuff that we talk about is like they called it, the hacking of the back door of the body. They're going to be able to hack how our body works and how our different biological systems work. And I have a really interesting story about using light. And again, this is probably one of these therapies here to steer the heart and to fix it. So we'll look at that. Anyway, let's finish this. So in 2013, GlaxoSmithKline created a $50 million venture capital arm called Action Potential Venture Capital to fund electroceutical startups. And its first pick was the vagus nerve implants company called SetPoint Medical. God, how many companies are there already? There seems to be quite a few. I'm going to drop that in chat while I'm reading. It's a little long story, but it's pretty good. SetPoint was co-founded by Kevin Tracy, a neurosurgeon and immunologist. So very interesting. He understands the brain and immunology, and he probably understands exactly how that gut-brain connection works. Motivated by the mysterious death of an infant burn patient under his care, Tracy went on to prove the existence of the, quote, inflammatory reflex a pathway through which the brain can quell inflammation by sending signals through the vagus nerve to the spleen. Setpoint Medical is dedicated to manipulating that reflex to treat rheumatoid arthritis and Crohn's disease, along with other inflammatory afflictions. Though this therapy requires an implanted stimulator, the small device that fits entirely in the patient's neck, greatly reducing the extent of the surgery. The company has always aimed to make this device as much like drug therapy as possible, explains Setpoint Chief Technical Officer Mike Faltes. We didn't get pharmaceutical funding until recently, he said, but we had the pharmaceutical idea from the start. Think about pills for a moment. You take them either on a schedule or in response to a symptom, and they're portable and their number can be limited by a prescription. The electrocores device shares all of these attributes. A typical regimen is 2 or 3 2-minute doses a day. But if you sense a migraine coming on, you can use the stimulator to head off a full-blown attack. Electrocores device is smaller than an iPhone 6, so it's easy to tote around. And the company's engineers recently built a stimulator into the case of a Samsung smartphone just to be shown it could be done, and it can be programmed by your doctor to deliver a set number of doses. Now, I was talking about that yesterday, the future of mobile devices, namely your cell phones, to be used in healthcare as biosensing devices, so you could like spit on your screen and get a diagnosis. Or now we find out also as a vagus nerve stimulator, potentially, to cure all of these other ailments. Making the world's first non-invasive nerve stimulator was quite an engineering challenge. Consider the signaling problem. The vagus nerve is made up of many individual nerve fibers of several different types, some transmitting signals up into the brain and some signals down to the organs. Some do helpful things, such as calming overexcitation in the brain or signaling the spleen to reduce inflammation, but others do things that could be dangerous, such as slowing your heart rate. And the signal must be able to activate the quote-unquote good fibers while leaving the quote-unquote bad fibers unchanged. Adding to the difficulty is that to reach the nerve, the stimulator has to transmit its signal through several centimeters of flesh without causing excessive muscle contractions. The signal must also pass through a layer of skin that's both electrically resistive and shocked full of pain receptors. Electrocore's research knew that directing the signal through the good fibers instead of the bad ones is just a matter of hitting the sweet spot of signal strength, and the real innovation was sending that signal painlessly through the skin, explains their vice president. The key, he says, is to understand that the skin acts the way a capacitor in a filter circuit does. It blocks direct current and low frequencies, but a high enough frequency signal will pass through it. But the brain responses to VNS are frequency dependent. And Electrocore's brain hacking code needs to be 25 1 millisecond pulses per second. But this low of a frequency would trigger pain receptors while passing through the skin. So the stimulator forms each of the 25 pulses from a burst of 5,000 hertz. What? Wow. This high frequency signal, this is kind of messed up. We got to look into what 5,000 hertz is and where that is on the electromagnetic spectrum. The high frequency signals slip painlessly past the skin, losing only about half of their strength along the way, and the nerve fibers themselves do the rest of the job, modifying the signal that reaches them so that only the train of 25 pulses remain to propagate up to the brain. Could you imagine? Like, I wonder if they could give you a frontal lobotomy with something like this. Just a few bzz, 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 and it's over. Don't worry about it. I mean, there was something here about being able to change your attitudes with magnets about immigration and your belief in God just recently. I wonder if this is part of the same thing. The handheld stimulator can produce pulses at a range of voltages because people's necks and nerves vary anatomically, and the voltage is adjusted for each patient, though it always remains below the level that would trigger the bad nerves. Electrocore's research found that the optimum voltage is about equal to the level that causes a person's lower lip to twitch. So if your lip starts twitching, you know that you're at about the right voltage. Oh my God. He says, my number is 28 volts. And that's the company's chief operating officer, Frank Amato, as he demonstrates the device. You get the sense that everyone at Electrocore knows his or her number. I tried it as well, and though on my arm, and with the goal of causing my hand to contract, and my number was 12, and that's the guy writing the story. Electrocore isn't alone in seeking a non-invasive way to access the vagus nerve. Germany-based Surbombed has developed a stimulator that hangs on a part of the ear where a minor branch of the vagus nerve lies close to the skin, and competitors are skeptical that stimulating this small branch will cause significant changes in the brain. But Surbombed cites studies showing that its stimulator produces a pattern of neural activation similar to that produced by more typical forms of VNS. And the company is now conducting a clinical trial for the treatment of epilepsy and has experimented with treatments for migraine, schizophrenia, and tinnitus as well. You might think Electrocore's non-invasive vagus nerve stimulator would have makers of more conventional systems worried, but hey, guess what? It doesn't. For those companies, it's all a matter of compliance and control. Compliance is the ability or willingness of a patient to follow through with the therapy, and as former Cybernetics staffer Morris points out, some of the company's patients may actually be too sick to reliably use a self-administered system. Some epileptic patients can feel their seizures coming on and activate their implants, but others don't experience such foreshadowing. So implanted stimulators can deliver their therapies automatically. Companies making invasive vagus nerve stimulators also like the guarantee that they can control the delivery of a precisely tuned signal to the vagus nerve alone. And Cybernetics is also working on a heart failure therapy in which the doctor carefully ramps up the electrical signal over many weeks. The Dallas company called Microtransponder is developing an implanted device to treat tinnitus and strokes. And the company's chief scientific officer says external stimulators could not match the timing precision and the signaling integrity of his system. Electrocore's Enrico acknowledges that compliance may be a problem for some patients, but he is convinced that his company's device has exact enough control to treat a broad range of ailments. Perhaps the biggest advantage of the non-invasive approach is the economics. Implants must operate inside the body for years without being damaged or causing problems themselves, and that does not come cheap. The U.S. government insurance program, Medicaid, what? So Medicaid actually pays for this, pays $20,000 for a Cybernetics epilepsy device and its implantation. At that price, it is not surprising that implants are often the last result, but by contrast, Electrocore's non-invasive system costs the equivalent to anywhere between $200 to $400 in Europe, depending on how many doses are programmed into the device. So they're going to get charges per dose. Like, how much is it? What's the difference of programming 5 doses versus 8 doses? Come on. Says, at that price, Medical University of South Carolina's brain stimulation scientist Mark S. George imagines a scenario that would be both a win for invasive and non-invasive technologies. Like any therapy, VNS does not work for everyone, and even in its most established use for epilepsy, VNS only helps about 40% of the people who get the implant. But George suggests that patients might start with the non-invasive stimulation, and if they respond to it, then go ahead with implantation. If clinical trials eventually prove this system's worth for other chronic ailments, its low price tag would make it competitive with standard drug treatments. And unlike pharmaceuticals, the nerve stimulator seems to have no major side effects yet. Hence the buzz about electroceuticals. Now, let's jump to this next story. This was just a little snippet I caught the other day out of Kurzweil's KurzweilAI.net website. And we had talked about this a while ago. Radio frequency heated iron oxide nanoparticles open the blood-brain barrier and could lead to direct delivery of drugs to the brain. So interesting that they're using this high frequency. We got to find out what 5,000 hertz is. This high frequency stimulation that gives them a direct connect to the brain. But we also know that electrical or electromagnetic frequency stimulation of different types to the brain open that much sought after blood-brain barrier to let in nanoparticles. A new method of opening the blood-brain barrier to deliver therapeutic molecules directly to the brain has been developed by researchers at the University of Montreal. The BBB, and that's blood-brain barrier, protects the brain from elements circulating in the blood that might be toxic to the brain, like nanoparticles, but currently 98% of therapeutic molecules are unable to cross the blood-brain barrier. Kurzweil AI has reported a number of recently developed techniques for delivering drugs to the blood-brain barrier, ranging from protein-based nanoparticles to most recently ultrasound, and we talked about that as well. But according to the principal investigator, Sylvain Martel, previous techniques either open the blood-brain barrier too wide, exposing the brain to greater risk, or they are not precise enough, leading to scattering of the drugs and possible unwanted side effects. To open the blood-brain barrier, researchers used a cannulation technique to deliver iron oxide magnetic nanoparticles to the surface of the middle cerebral artery of mice. Wonder what that middle cerebral artery is and how connected it is to the vagus nerve. They deliver iron oxide magnetic particles to the surface of the middle cerebral artery of mice. And in a previous study, they showed that MRI could then guide the nanoparticles to a desired location. Then they applied I don't know what that was. That just scared the crap out of me. Then they applied a radio frequency field to heat the nanoparticles, which then dissipated the heat, creating a mechanical stress on the blood-brain barrier. That allowed for a temporary and localized opening of the barrier for diffusion of a visually identifiable dye, which was representing a drug, for approximately 2 hours into the brain. This is very scary. I mean, the blood-brain barrier exists for a reason, and they want to put these untested nanoparticles, which accumulates in different bodily organs, right directly of the blood-brain barrier. In this study, we show that thermal energy generated by magnetic heating of commercially available magnetic nanoparticles in the brain capillaries of rats can transiently increase barrier permeability. So there you have it. Targeted drug delivery systems directly to the brain. All right, now we're going to look at the heart, because this was something else. Researchers learn how to steer the heart with light, and that's why I think that this has something to do with that VNS stimulation. We depend on electrical waves to regulate the rhythm of our heartbeat, but when those signals go awry, the result is a potentially fatal arrhythmia. But now a team of researchers from Oxford and Stony Brook universities has found a way to precisely control these waves using light. And the results are now published in the Journal of Nature Photonics on October 19th of 2015. Both cardiac cells in the heart and neurons in the brain communicate via electrical signals, and these messages of communication travel fast from cell to cell as excitation waves. And interestingly, such waves are also found in a range of other processes in nature, from chemical reactions to yeast and amoebas. But for heart patients, there are currently two options to keep these waves in check: either electrical devices such as pacemakers or defibrillators, or drugs such as beta blockers. However, these methods are relatively crude. They can start or stop waves, but they cannot provide fine control over the wave speed and the direction. This is like being able to start or stop a boat, but without the ability to steer it. So this research team set out to find ways to steer the excitation waves, borrowing tools from the developing field of, again, optogenetics, which so far has been used mainly in brain science. Optogenetics uses genetic modification to alter cells so that they can be activated by light. Now, this is twice we have heard about this technology, or maybe even 3 times. And until now, and this was something that DARPA was messing with again, wanted to use this to very precisely control the activity of millions of cells. So, I don't know, the story goes on and on. It says the team stresses that there are significant hurdles before this could offer new treatments, but the key issue is being able to alter the heart to be light sensitized, so they're going to make it glow in the dark, and then be able to get the light to desired locations. However, as gene therapy moves into the clinic, yes, people lining up for clinical trials, and with the miniaturization of optical devices, some sort of nanofiber optics inserted into the heart or the brain, like they've been doing in mice, they use all of this optical technology. The use of all this optical technology may become possible. But in the meantime, the research enables the scientists to look into the physics behind the many biological processes, including those of our own brains and hearts. And I think where we're going to end this show, mind hack, scientists use magnets to change out and dramatically change people's attitudes to immigration. What? Psychologists use a magnetic force to safely shut down the region of the brain associated with threat response functions, and conducted a series of tests where volunteers were asked about their beliefs. And I am pretty certain that, again, this was some of the research that DARPA was doing on PTSD patients. Scientists found that people were less likely to have negative views when the magnetic force was applied to the posterior medial frontal cortex, positioned a few inches up from the forehead. In the study, half of the participants were given a low-level placebo-like magnetic energy that did not affect their brain, while the other half received enough energy to lower activity in the target area. Volunteers were then asked to think about death, after which they were asked questions about the religious beliefs and attitudes about immigration. Researchers from the University of York and the University of California at less belief in God, angels, or heaven. What? Yeah, here we go. Now let's get the rest of the public to not believe in religion. What's really interesting about this is using these magnetic fields and discovering that there was a large decrease in the belief in God's, angels, or heaven. And then we see over the last 20, 30, or 40 years how the belief in religion has really plummeted into the toilet. And we have a huge agnostic society now that completely lacks ethics and morals. It makes you wonder if these electromagnetic frequencies in our atmosphere haven't had something to do with it. All right, guys. Well, guess what? We are about out of time. Make sure you stick around. It's Thursday. Mr. Kevin Blanche is up next. Game On with Ron Stevens at 7. Behind the Woodshed with Hal Anthony at 8 p.m. Eastern. Double Cross Radio with Chuck. It's always a good one at 10 p.m. And the Anti-Media Radio with S.M. Gibson at 11 p.m. Eastern. I really hope that I am still broadcasting. They apparently did upgrades to my neighborhood last night, and I still think I'm having some difficulty